Alright, we are going to discuss about the remaining two concepts of ratio and proportion, which are continued proportion and mean proportion. First of all, we will discuss about continued proportion. The statement of the concept of continued proportion is that if three numbers a, b, c are in continued proportion, then it means that a, b, c are in proportion. It means that the ratio of a is to b is equal to the ratio of b is to c, because as the statement of continued proportion state that if three number a, b, c are in continued proportion, then a, b, and c are in proportion. That means the ratio of the first two terms is equivalent or equal to the ratio of the last two terms. So the ratio of the first two terms is a ratio b, which is equal to ratio of the last two terms, which is b ratio c. That's why a ratio b is proportional to b ratio c. This is the meaning of the concept of continued proportion. Now we can see here that the middle terms, as I have earlier told you, that these two terms are the middle terms and these two terms are the extreme terms. So using the previous discussed concept of middle terms and extreme terms, we can conclude that the product of middle terms is equals to the product of extreme terms. That means product of b and b, which is b square, is equal to the product of extreme terms, which is a multiplied by c. That means in continued proportion, the square of the middle term is equal to the product of the extreme two terms, which are a and c here in this case. So b square is equals to ac when a, b, c are in continued proportion. This is the most important result which we have to remember for solving the problems based on continued proportion. The result being that b square is equals to a multiplied by c, where b is the middle term and ac are the extreme terms of the continued proportion. Now the last concept of the ratio and proportion is mean proportion. This concept is basically a derived concept of the continued proportion. This states that if three numbers a, b and c are in continued proportion, then b is called the mean proportion between a and c. Instead of saying this as a concept, we can also say that this is mere a definition. This is definition for mean proportional. Mean proportional is the term which is in the middle of the continued proportion between three numbers. If a, b and c are in continued proportion and they are numbers, then the middle term b is called the mean proportional between the two extreme terms a and c. Similarly, for solving the problems of mean proportional, we can use the formula which we have derived in the continued proportion, that is b square is equals to ac if a, b and c are in continued proportion, or b is the mean proportional between a and c. This means a, b, c are in proportion. Means the ratio of a is to b is proportional to the ratio of b is to c, or fraction a by b is equal to fraction b by c. This is all about the concept of ratio and proportionality. Now we are going to see some examples. Check whether 36, 49, 6, 7 are in proportion or not. Let us see the solution. The given numbers must be mentioned in the order in which they are given. If you done any changes with the order of the numbers, then you are attempting the wrong question. Alright, if the numbers are given in this sequence, such as 36, 49, 6 and 7, then the proportionality of these numbers must be checked in the order. In the order, what I mean by that is 36 ratio 49 must be checked with the proportionality of the ratio 6:7. Now we can write 36, 49, 6, 7 to check whether they are in whether they are in both proportion or not, as 36 ratio 49 is proportional to 6 ratio 7. Now 36 ratio 49 can be written in the fractional form as 36 divided by 49, while 6 ratio 7 can be written in fractional form as 6 upon 7. Now checking in the first fraction, is there any common factor between the numerator and denominator other than 1? We get that 36 can be written in its prime factorization as 2 multiplied by 2 multiplied by 3 multiplied by 3, and 49 can be written as in its prime factorization as 7 multiplied by 7. So there is no common factor between the numerator and denominator in the first fraction. Similarly, in the second fraction, 6 can be written in its prime factorization form as 2 multiplied by 3, and 7 in its prime factorization form is 7 multiplied by 1. So there is no common factor between the numerator and denominator of the second fraction also. So 36 divided by 49, this fraction is in its lowest or simplest form. Similarly, 6 divided by 7 is also in its lowest form, and there is no common factor between the numerators and denominators of both the fraction other than 1. That's why we can conclude that 36 divided by 49 is not equals to 6 divided by 7. So these two fractions are not equal, and these two fractions can be represented using the ratio representation. 36 divided by 49 can be written as 36 ratio 49, and if their fraction are not equal, fractional representation are not equal, so their ratio representation is not also equal. So 36 divided by 49 is not equals to 6 divided by 7. That's why 36 ratio 49 is not proportional to 6 ratio 7. Now taking another example, if 3 ratio x is proportional to 12 ratio 20, find the value of x. The solution is, it is given that 3 ratio x is proportional to 12 ratio 20. That means the fraction 3 divided by x is equal to the fraction 12 divided by 20. Now using the concept of cross multiplication, I can state that 3 multiplied by 20 divided by 12 is equals to x. Cancelling the common factors between the numerator and denominators, 20 is cancelled by 4 5 times, 12 is cancelled by 4 3 times, and this 3 is cancelled by the numerator 3. That means x is equals to 5. Now we can verify the result also. We get the result as x equals to 5, and it is given that 3 ratio x, which is equals to 5, is proportional to 12 ratio 20. We can check that whether x is equals to 5 or not according to the given condition in the question. Now 3 ratio 5 can be written as 3 divided by 5 in the fractional form, and 12 ratio 20 can be written as 12 divided by 20 in the fractional form. Now there is no common factor between numerator and denominator of the first fraction, which is 3 and 5, 3 divided by 5. Similarly, in the second fraction, we can see that there is a common factor of 4 between the numerator and denominator. So 12 can be written in its prime factorization form as 4 multiplied by 3. 4 is multiplication of 2 and 2 in its prime factorization form, and similarly 20 can be written as 4 multiplied by 5. This 4 get cancelled, and 12 by 20 in its simplest form is equal to 3 by 5. That's why the first fraction is equal to the second fraction. So x equals to 5 is the correct result. Let's take another example. Find out the fourth proportional to 4, 9, 12. The solution is, we have asked about the fourth proportional. That means the fourth term after 12, so that the 4, 9, 12 and the term which we are going to find out should be in proportion. That means let us assume the fourth proportional equals to x. Now according to the given condition 4, 9, 12, x, this is the fourth proportional. That's why this comes in the last place. Should be in proportion. That means 4 ratio 9 must be proportional to 12 ratio x. 4 ratio 9 can be written as 4 divided by 9 in fractional form, while 12 ratio x can be written as 12 divided by x in the fractional form. And if they are in proportion, then their fractional representation must have equal values. That's why 4 divided by 9 is equals to 12 divided by x. Now using cross multiplication we can conclude that x equals to 12 multiplied by 9 divided by 4, and cancelling the 12 in the numerator with the 4 in the denominator by a factor of 3, we get x equals to 27. So the fourth proportional to the three numbers 4, 9, 12 is 27. Now we can verify the result whether 4, 9, 12, 27 are in proportion or not. So if they are in proportion, that means the ratio of the first two terms is equal to the ratio or is in proportion with the ratio of the last two terms. That means 4 ratio 9 must be equal to or proportional to 12 ratio 27. Now we can see that there is no common factor between 4 and 9 if 4 ratio 9 is represented in the fractional form. So 4 ratio 9 in its simplest form can be written as 4 divided by 9 in fractional form. Now 12 divided by 27, which is the fractional representation of the second ratio 12 ratio 27. Now there is a common factor of 3 between the numerator and the denominator. Cancelling that factor and reducing the numerator and denominator to their simplest form or the fraction to their simplest form, we can conclude that 12 ratio 27 is equals to 4 ratio 9, or 12 divided by 27 equals to 4 divided by 9. That's why our result is correct. X equals to 27. Let us take one more example. Find the third proportional to 16 and 36. Now it is given that the third proportional which we have to find, let us assume it to be x. Now as you can see that only two numbers are given. That means these three numbers, including the number which we have to find, which we have assumed as x, must be in continued proportion, because we cannot find two numbers using two numbers in a proportional concept. Alright, we can find a single number using the two numbers by using the concept of continued proportion. So these three numbers must be in continued proportion so that we can find the value of x. Now if they are in continued proportion, that means 16, 36, 36, x are in proportion. Then the ratio of the first two numbers is equal to or is proportional to the ratio of the last two numbers. That means 16 ratio 36 is proportional to 36 ratio x. That means 16 ratio 36 is equals to 36 ratio x. And this ratio representation can be converted to the fractional form as 16 divided by 36 is equals to 36 divided by x. Now using the cross multiplication method, I can conclude x equals to 36 multiplied by 36 divided by 16. This reduces after cancelling the common factors between the numerator and denominator to 81. So x equals to 81. Now we can check or verify our result as 16, 36, 81 are in continued proportion or not. This C dot represent continued and this sign represent proportion. So these three numbers to be in continued proportion, that means these four numbers means 16, 36, 36, 81 should be in proportion. That means the ratio of the first two numbers is proportional or equal to the ratio of the last two numbers. That means 16 ratio 36 is proportional to 36 ratio 81. Now 16 ratio 36 can be represented as 16 divided by 36 in fractional form, and ratio sign, the sign of proportionality I am replacing with the sign of equality, and 36 ratio 81 can be represented as 36 divided by 81 in fractional form. Now cancelling the common factors between the numerator and denominators of the two fractions, I'll get the first fraction as 16 divided by 36. The numerator is cancelled by 4, leaving a quotient of 4, and the denominator is cancelled by 4, leaving a quotient of 9. That means 16 upon 36 is equals to 4 divided by 9 in its simplest form, and similarly 36 divided by 81, cancelling the numerator and denominator by 9 by a factor of 9 and leaving the quotient as 4 in the numerator and a quotient of 9 in the denominator. This is equals to 4 divided by 9 in its simplest form. That's why the two fractions are equal in their simplest form. That's why our result which we have derived for x, which is equals to 81, is correct. Now let us take one more example. Find the mean proportional, m dot means mean, this sign is for proportionality, mean proportional between 0.08 and 0.18. Let us see the solution. We are asking about the mean proportional between 0.08 and 0.18. Let us assume the mean proportional between them as x. Then the mean proportional is the middle term. So 0.08, x, 0.18 must be in continued proportion. And using the formula that the square of the middle term means x square is equals to the product of the extreme two terms. Is the product of the extreme two terms means 0.08 multiplied by 0.18. Now x is equals to the under root of the product of 0.08 and 0.18. Now we can see that 0.08 can be represented as 8 divided by 100, and 0.18 can be represented as 18 divided by 100. Now multiplying the numerators and the denominators, we get x equals to 8 multiplied by 18 in the numerator divided by 100 multiplied by 100 in the denominator, whole under root. This reduces to 8 multiplied by 18 is equals to 144, and 100 multiplied by 100 is equals to 10,000, and whole under root, that means x equals to under root 144 divided by under root 10,000. Under root of 144 is 12 and under root of 10,000 is 100. That's mean x equals to 12 divided by 100 in fractional form, and if we can convert this in decimal form, we get 0.12 is equals to x. That means 0.08, 0.12, 0.18 are in continued proportion. We can also verify our result. If they are in continued proportion, that means 0.08, 0.12, 0.12, 0.18 must be in proportion. Let us verify the result. If they are in proportion, then the ratio of the first two terms is proportional to the ratio of the last two terms, or is equal to the ratio of the last two terms. Then we can write 0.08 ratio 0.12 is proportional to ratio 0.12 is to 0.18. Now this sign of proportionality can be replaced by the sign of equality, and this sign of ratio can be replaced by the sign of fraction or division between the two terms antecedent and consequent. 0.08 makes the numerator of the fraction, and 0.12, which is consequent, makes the denominator of the fraction. Similarly, 0.12 ratio 0.18 in its fractional form can be written as 0.12 divided by 0.18. Now cancelling the common factors, first rejecting these two decimal points with an equivalent replacement of zeros in the digits after decimal, we get 8 by 12 as the first fraction and 12 by 18 as the second fraction. Now cancelling the common factors, we get 8 by 12 is equals to 2 by 3. Similarly, cancelling the common factors between 12 and 18, which is 6, so the numerator reduces to 6 multiplied by 2, it is equals to 2, and the denominator is 6 multiplied by 3, it reduces to 3. So 12 by 18 in its simplest form can be written as 2 by 3, and these two fractions are equal, as we can see, so our result is correct. Let us see one more example. What must be added to the numbers 6, 10, 14, 32 so that they are in proportion? Let us see the solution. Let the required numbers to be added to these four numbers be x so that they are in proportion. That means if I add x to each term of this series, then the result which I have get is these numbers 6 plus x, 10 plus x, 14 plus x, 32 plus x. Now it is said that if the number which we have to find is added to each term, then the result which we get the four terms are in proportion. That means the ratio of the first two terms, which is 6 plus x ratio 10 plus x, is proportional to the ratio of the last two terms, which is 14 plus x ratio 32 plus x. Now this ratio in fractional form can be written as 6 plus x divided by 10 plus x. In this ratio, this sign of proportionality can be replaced with the sign of equality, and the second ratio can be written as 14 plus x divided by 32 plus x. Now using the concept of cross multiplication, I can say that 6 multiplied by x, 6 plus x multiplied by 32 plus x is equals to 14 plus x multiplied by 10 plus x. Multiplying the first two terms in the LHS, I'll get x square plus 132 plus 28x, and multiplying the two terms in RHS, I'll get x square plus 140 plus 24x. Now cancelling the term x square from both the LHS and RHS, I am remained with the term 132 plus 28x is equals to 24x plus 140. Now carrying the similar type of terms to one side and the other type of terms to other side, that means 132 and 140 are independent of variable x. That means there should be one side of the equation 132 minus 140 is equals to, and 28x and 24x are of similar type. They have a dependency on x with power 1. That means they are multiplied with the term x, should be carried on one side. That means 24x minus 28x. This is equals to 132 minus 140 is equals to minus 8, and it is equals to 24x minus 28x equals to minus 4x. This gives me result minus 8 divided by minus 4 equals to x. That means x equals to 2. Now I can verify the result if x equals to 2 is correct or not for the given condition. The numbers which we are given with is 6, 10, 14, 22, and it is given that if x is added in each term, then the resultant terms are in proportion. We get x equals to 2. That means 6 plus 2, 10 plus 2, 14 plus 2, 22 plus 2 must be in proportion. That means 6 plus 2 is 8, 10 plus 2 is 12, 14 plus 2 is 16, 22 plus 2 is 24. These four numbers must be in proportion. That means the ratio of the first two terms, which is 8:12, is proportional to the ratio of the last two terms, which is 16:24. Now these ratio representation can be written as 8 divided by 12 in the fractional form, and this sign of proportionality can be replaced with the sign of equality. The last ratio 16:24 can be written as 16 divided by 24 in fractional form. Now if they are in proportion, then these two fractions must be equal. Cancelling the common factors between the numerators and denominators of the first fraction, I get 8 by 12 is equals to 2 by 3. Similarly, cancelling the common factor of 4, cancelling the common factor of 8 between the numerator and denominator of the second fraction, I'll get 16 is equals to 8 into 2, which means 2, and 24 equals to 8 into 3, which means 3. Cancelling the common factor of 8, I get 16 upon 24 equals to 2 upon 3, and we can see that these two fractions are equal. That's why our result is correct, and the number x that should be added to each term of the series 6, 10, 14, 22 is 2, so that the resultant four numbers are in proportion. Alright, let us see one more example. If 3 loaves of bread are consumed by 9 people, 3 loaves of bread is consumed by 9 people. How many people will consume 9 loaves of bread? How many people consumes 9 loaves of bread? This question can be done using the concept of unitary method, and also it can be done using the concept of proportionality. The solution is, let the number of people who consume 9 loaves of bread equals to x. Now we can see that there is a direct proportionality between the number of people and the number of loaves of bread. What I mean to say is that if the number of people increases, then the consumption of the number of loaves of bread also increases. This means these two quantities are directly proportional. So in the first case, there are 9 people and they consume 3 loaves of bread. So in the second case, let the people is x and they consume 9 loaves of bread. So these 4 terms must be in proportion. That means 9, comma 3, comma x, comma 9 are in proportion. This is the number of people, this is the number of loaves of bread which this much people consumes. Similarly, this is the number of people and this is the number of loaves of bread which these people consumes. So these four numbers must be in proportion. That means 9 ratio 3 is proportional to x ratio 9, and the first ratio can be written as 9 divided by 3 in fractional form, replacing this sign of proportionality with the sign of equality. I can write the second ratio x ratio 9 as x divided by 9, and by using the cross multiplication method I can conclude that 9 multiplied by 9 divided by 3 is equals to x. This leads us to the result x equals to 27. Hence 27 people will consume 9 loaves of bread. That is all about the concept of ratio and proportion.